I don't know why I have a bookmark sitting on my table, but there it is. Without a book, it's just a bookmark.
At that point, it's just a piece of paper.
It's just a mark.
This is Mark.
Oh, hi, Mark.
Well played.
Welcome, everyone, to another great episode of the Do Better Dev Show. Today is extra special because your third favorite co-host, Nathan, is here to talk about functional programming.
The big day again. It's a really big day.
Biggest yet.
I would say
2021 is just... Yeah.
Yeah, it's our... We had a nice warm-up round attempting to record this once. So it's going to be even better than a normal discussion.
That's true. That's what they say. Do it once, it'll be sad. Do it twice, it might just be a little bad. And I just made that up.
I figured, yeah. So for those who haven't gathered it, Gyan's favorite thing is not functional programming. But I really do like it. So this episode is going to be mostly about me talking about how I like this stuff. And hopefully Gyan providing some color commentary on stuff that maybe he just doesn't like or things I might have missed. So
yeah, I think you're just recruiting an army of people who like functional programming to rebel against me at this point. And yeah.
It's a hostile takeover.
And that's okay, because how long am I going to be the fourth favorite co-host? So.
Well, you got to be replaced by someone who's a bit more pure.
No. See, I don't think they'll function quite well.
Ugh, it hurts so much. So, again, before we get into the discussion, the topic for the day, I got to know, it's been a couple days since we last recorded. Did you do anything interesting or rad or horrible even that you want to share?
Interesting. Those are three of my favorite categories. So what I'm gonna and all of this positive attitude is coming from I have switched over since I canceled my Netflix subscription. Now I've switched over to Prime, and I used to binge Office on Netflix. So now I binge Parks and Rec on Prime. So all this is literally the best show ever. So that's where the excitement is coming from. I'm channeling my inner Chris Traeger. Mm-hmm. So that's been a great thing that has happened in the last week. And interesting thing that I did read that's actually relevant to this podcast is that article you sent me about how asynchronous programming isn't the greatest.
And in Python specifically.
I think that rule more or less applies to most languages, because the essence of that article was more threads doesn't mean better processing, because your system will hit limits.
Yes. It also, we'll go into this for a minute. It was talking about as well, specifically with Python, how a lot of intensive sections or libraries are often written in C. And that gives you a performance gain there. And if you're doing asynchronous Python, it will be written in Python, which is going to be slower than C. And the other piece was, if you're using asynchronous Python, it's not being managed by the kernel. Its threads are managing more or less by what the article was saying themselves. So they might essentially hog a lot of the resources that need to be available to another thread, so that thread can't get started or do whatever it needs to do at that time. So you're not getting the actual parallel execution of these things because one is being starved for resources. So in other models that have something that can run code asynchronously via threads that's centrally managed, that could work just fine. But in the case of Python, at least, it's not managed that way.
Yeah, and that was sort of the fun thing of always remembering that. Because until you go to the very bare bones, that's why threading in C is great. I mean, besides all the memory allocation issues that you have to always look out for, it's great because it uses fork and it talks directly to the kernel because it's a low-level programming language. But yeah, that was the thing with Python. Every time I've programmed with threads and or processes in Python, I always take the model of I am literally copy pasting my code and running it in separate executions. And that's essentially what Python does under the hood. It just spawns out different things, and depending if they're process or threads, they do share the same memory space or not. Besides that, yes, if you have one of the threads go haywire, it can eat up the entire CPU, get killed by the kernel, and essentially take down the app, depending on how severe or memory space it's taking. And yeah, so definitely very cool. The most important thing I did get out of it, which I really like, is that the concept of more threads does not mean more performance. And I can't wait to sass somebody about it when they're just like, why don't you just increase the performance? I'd be like, why don't you just add 100 gigs of RAM to this? So yeah, and that was also one of my complaints when I was initially doing threading in Python, because Python is a memory hog, and you can do more of it. You can have a okay CPU, but you better have a lot of RAM. If you think Java takes up RAM, wait till you run Python in threading, and then you'll be very sad. Yeah, so that was the rad thing that happened,
Mhm.
and the bad thing I can't really remember because Chris Traeger,
That's
nothing
right.
goes wrong.
That's right. I'm literally the perfect human. So yeah, um, the thing it was comparing in that article, I just wanted to circle back on that real quick, is they were comparing REST frameworks primarily, I think, of Python with C implementation, so synchronous Python with asynchronous Python, that's pure asynchronous Python, which is why there's that discrepancy with asynchronous versus synchronous code, um, because you don't get the benefits of C in so many of these newer frameworks.
Yeah.
So,
Oh, also a good call out that they did was whenever you see these benchmark results,
mm,
look at what their parameters was. There's a lot of times when I look at certain benchmarks and I'm like, oh hell yeah, this is so much better. But it always, unless I'm critical of that product, I never really go ahead and say, okay, but what were the parameters? What were the variables?
right.
I know for graphics card, I'm very much like, well, what? How did they run the game? What was the other things?
Yeah.
But when it comes to certain language and frameworks, I'm just like, this is faster. Let's use this before realizing that may not be the model or traffic that your application handles.
Right. So I guess at this point now, I'll need to remember to link this article in the description and notes. So I will do that. So yeah, from my last few days, and I did. I mentioned in the last episode that I wanted to get a better set of teammates in Rocket League by being a better Rocket League player. So I watched a bunch of videos on YouTube about how to be better at Rocket League. And one of the common suggestions was to play 1v1, where essentially you're the only one that can make the mistake, and if you make the mistake, you pay for it. So I played some of that, and it's definitely tough, but I'm on a 3 game winning streak on 1v1. And then this morning, I played a one off standard, which is 3v3 game. And I just felt like I had such a better idea of what I was doing relative to the ball. So progress is being made in Rocket League, which nobody cares about, but I'm having a lot of fun with it.
Hey, you
And
don't know that Master 69 might be looking forward to you as a team member.
that's right. It actually reminded me. So when I was doing the uh, computer design, digital logic layer stuff in Minecraft, the channel I was learning from is called Nubosaurus. So it's a he deserves a lot more subs because the content's really good. It's so niche, like specifically learning about digital logic through Minecraft computers. It's such a small group of people, but he's got 2,000 subs or something, and it's a really good channel. He's been making content for years. So if any listener is curious, I'd say go check him out. So yeah, maybe whatever you said, noob something 69 really cares about my Rocket League skill or lack thereof. And the other thing is I might be doing some longboarding with one of my friends. So it hasn't happened yet, but we started discussing it over the weekend. So that would be nice to have someone to skate around with.
Are
And that's
you a good skater?
I'm more than pretty good, I say. I have my own skate company. But yes, functional programming.
Yes.
It's something that we should discuss because it is the topic of this episode.
Yeah.
And so I made you do this last time. I'm going to make you do it again. Can you define functional programming for us?
Oh man, I've crossed out all my notes from the last time. So
Well, that was foolish.
I know.
See, the
So
problem here again is that you mutated your notes.
I did. I did. I should have made sure they didn't share state, and
Correct.
now they're altered, and now I don't know what I'm talking about. But what I'll say is, if I hadn't done that, what I would expect functional programming to be at the very base is given a function x, depending on the input I give it, it always gives me a consistent output based on the input. So if my input value is x and it gives me y, next time if I give it x again, it always gives me y and not z or anything else. That's at least what I remember from Calc 101 about what functions are and pure functions and other mixed words, but
Right.
that's how I would describe functional programming. And it doesn't it's like the most zen kind of attribute that exists. It's like no nonsense. It doesn't have all these worldly concerns and clutter in its head. It's just a monk sitting there and you go to it and you're like, if I ask you this question, will your answer be the same depending on the person? And they're like, nah, I don't care who you are. For all questions, there's a different answer, and there's this only one answer for you, and then it
Wow.
gives you that.
That's the strangest metaphor I've heard to describe mathematical
I
functions.
just made it up too.
Yeah. So, yeah, a lot of functional programming has to do with a background in mathematics. This is where a lot of the functional programming content that gets really confusing tends to come from, is from people with a background in math. And yes, these functions that you typically use in a standard high-level program tends to be what are actually called procedures, and those can have side effects. And so a side effect is something happening outside of the function itself that doesn't just relate to, like Gyan mentioned, inputs and outputs. And so if you're building a program around pure functions, which are functions that just accept inputs and give you the same output based on those inputs, then a lot of simplicity can be derived from the processing of that data, because you know that, for example, no matter how many times you run that program, given the same input, you get the same output. So there are some specific benefits, and I want to cover those initially, and then we'll start diving into a bit more about the specifics of functional programming principles. So ironic that we started this conversation with threading, because one of the benefits of functional programming is parallelizing your computation. And that's because functional programming is based on minimizing or sometimes completely removing shared state, at least from large areas of the code. And if there's no shared state, then you can spread the operations across multiple threads, multiple machines. They can really be run anywhere. And then as long as there's a way to combine those results again at the end, then you can complete that operation. So something that would be done with is, for example, Mapreduce, which is, I think, popularized as a Google thing, but it essentially takes a huge input of data and breaks up the processing of it across a ton of machines, and then aggregates that data, in other words, reduces it again at the end. And so when you have the actual formula for it is something like associativity plus closed data equals parallelizable, meaning that if you're staying in the same data type and it doesn't matter what order everything completes in, then you can parallelize it. So the example with MapReduce that's really easy to understand would be something like counting the number of times a certain word appears in a book. And then you could map each page to a machine. Say you have 500 machines, and you're going to map 500 pages to those, one to each machine. Each machine can then, in parallel, count the number of instances of that word, and then you reduce them all together. And because addition is associative, meaning it doesn't matter which side the plus operator, essentially the number is on, you get the same answer. You can just smash them all together at the end, and now you have the count for how many words or how many instances of that word exist in that 500-page book. But it took you the amount of time to calculate how many instances of that word are on one page. So for something like Google, with a huge amounts of data, that idea is very promising and important, and it's useful, and it's made easier with principles from functional programming, which, for example, are pure functions. So I need to take a drink of water, and then we'll move on to the next thing.
All right. That sounds like a great way to reduce something from O to the N to the O to the 1.
Yeah, potentially. If you know the
At least
size
for time.
the size of each segment, yeah.
Yeah, the space complexity goes crazy, but the time
Yes.
complexity is great.
Yeah, it's essentially if n was number of pages, then yeah, you've just got a constant number of pages. Assuming the pages are somehow always the same size, then yeah. O1.
Wow.
Bam.
That's crazy. That's good.
Yeah. So
that's what we need in life. Yeah.
Yeah. So another big piece is how to manage state when it does get involved. So as mentioned, one of the main goals of functional programming is to remove state from all of your logic whenever possible. And that's because the difference between functional programming and object-oriented programming in many ways is their approach to solving the state problem. And so everybody sort of is aware that state is messy and difficult, but essential. And object-oriented programming typically says, this is difficult to manage. If you have a ton of data, a ton of state, it's difficult to manage, so we should break it into these small chunks and encapsulate that logic. So if you have some state about users, you put it in a user model, and the user model knows how to work with that state and emit signals that other things can listen to.
So for non-JavaScript fans, state is just data, just the context of what's happening.
Yeah, state is any variable that can change over time and be referenced in more than one place.
Okay.
So if you have, if you've worked in the back end of any system that connects to a database, it's one massive global variable. You just call it a database. And it's this big piece of mutable state, mutable meaning that it can be changed. And if you couldn't change the data in your database, it'd be kind of useless, just a massive...
Read-only databases.
Massive constant.
It just never changes, yeah.
Yeah, so at that point, it's no longer stateful. It's just a big piece of hardware that stores a ton of information.
And you can just copy-paste that onto the front end directly.
Yeah,
Skip the back end.
Straight into your Redux store. And on the front end, something like Redux is where you tend to keep most of your application state. So if you've worked in one of those two areas, those are super common places for dealing with state. Within a smaller situation, if you have a function and it, for example, can reference a variable outside of itself, that is in a way referencing state. Even if it looks like that variable can never change, if somehow the reference to that variable changes, it would be having an effect on that function, making it somewhat impure. And anything that can be potentially impure is not pure, and that's not the goal of functional programming. So point is, to get back to how functional programming manages this state problem, is when you've removed as much state from your code as possible, you have to keep it somewhere. And functional programming tends to say, let's keep it out of as much of our code as possible and then push it to the edges of the application. And so something like, again, the Redux store, because that's a pattern I'm familiar with, and it's based on a lot of these principles, you've got this purely functional, almost entirely purely functional framework called React. And it has some component level state, but at a high level, looking down at it, it's just props that render out to the UI, and it's very much based on one-way data flow. A lot of the stuff you would think of as just one big function. And then you have your Redux store, which is just bolted onto the side. And it's this big, ugly, like tumor on your application that in order to communicate with it, you send a signal out to it. And you're like, I want to update this counter. And it goes, all right, I'll do that for you. Updates the counter and then passes that new input through the rest of your React application. And so the way that it's been done in that particular example is said, we have all this display logic, all this rendering logic, all this UI structure. Let's make that as stateless as we can, rip it all out, and just put it on the side. And then to communicate with it, you have to let it know that you would like to change something, but it's not even you get to access it directly, because that would make your application more complicated, or more complex, I should say. So something like Vue, they may have removed it completely, but last I checked, Vue allows you to do two-way data binding, where you can have a reference directly to some shared state and modify it in place, and that updates the shared state. Whereas with React, you have to say, I want to make a request to update this. Once it's updated, that gets passed back through as an input. So again, the two different approaches: break the state into small pieces versus push the state out to the side, and they solve very different problems. The fact that Angular was a big mess that we all hate it is largely due to the idea of trying to take something like MVC, which works really well on the back end, and shove it into the front end and use all this context and scope and all these big, gross pieces of shared state and say, we can totally make UIs out of this. And if you've ever looked at an Angular code base, Angular 1 code base that's more than a year old, you know that that's not true. Whereas you hop into a React code base and it can sure be designed poorly by certain teams, but in general, if you go into a file, you just see what the UI for that component is going to look like, what props it receives, and you see what it's going to render. And that's pretty much it. Like, there's not much else it can do because it's intentionally been designed that way, especially now that class components are gone. Or not gone, but there's no reason to use them anymore.
Yeah, and they're phasing them out pretty much.
Yeah. And they always felt like the thing React hadn't figured out how to do yet, to me. It was like, we have all these good ideas, but we haven't worked out how to do this component level state thing yet. So you had these class components. And then when hooks got brought in and added use state, it was like, we don't need these anymore. Finally, you can have this beautiful application that, again, the code itself might become messy if you don't reg it very well. But if you zoom out just one level, you can just see data flows through your application in one direction as inputs, and you get outputs. And for UIs, that seems to be a problem that we've realized works really well for functional programming. And if you're not familiar with the concepts that are informing the design of something like React, you're probably at a disadvantage to someone who does understand what the benefits of functional programming are and why something like that works. Otherwise, you're just trying to look at something like Angular versus React and say, why does one work and one really doesn't?
Yeah, so when it comes to functional programming, sharing is not caring. Because
Indeed.
you push it as much as you can.
That's right. Yeah. Sharing is a bad idea in functional programming. And so what you can end up building a lot of really well in functional programming are these input and output processing pipelines. And so where you'll see functional programming really shine in like a standard backend application, for anyone who's listened to any episodes will probably know this. I work with Django quite a bit right now, and you'll have a lot of object-oriented stuff. And then if you need to offload some data processing, you can toss it into a task or something like that, where a lot of the data manipulation itself can essentially just be pure functions. And then those are really easy to test. You can pass inputs in, gives you the new result out. And with that new result, you can then toss it into the database. So you've got most of it being very straightforward. You understand the input, you get the output, and there's just that last little bit that is a side effect, which is actually toss that new value into the database so that the rest of the application can know about it. High level, I think that has been a reasonable explanation, I hope, of some of the benefits and examples.
Can you give me some examples of impure function? The evil ones, the one that needs holy water on top of them.
Yeah. So as I mentioned, if you have say a variable, and we'll say it's actually a variable, not a constant, in any language, that is defined on, say, some sort of global scope relative to this function. So other functions within that file have access to that variable as well and could mutate it. If looking at the code, you see, well, nothing else actually modifies this variable, it doesn't actually matter that none of the other functions appear not to modify that variable. If your functions are all referencing that shared variable, you can't be confident that it's actually going to behave as a pure function. So sometimes it's obvious if you have a count defined outside of your function and then you're looping inside your function, yes, that count is going to change as you modify it with each iteration. So that would be explicitly impure. On the other hand, there could be something that you're just referencing what appears to be a config variable or something, but based on what that config variable is, your function could behave differently, or it should, otherwise why are you including it in your function? So given something that has changed, other than the explicit inputs provided to that function, it gave you a different result. So it no longer satisfies the pure function definition that you discussed at the beginning. So that would be some very basic examples of impure functions. You could go with like a random number generator. If you run it and it gives you a different number each time, it's not actually pure. Something like the date function in, say, Python, if you run timezone.now, it's actually giving you a different answer every time you run it. So it's impure. If you were able to give it some sort of seed that said, this is the time or something, and then it gave you back the time as a date time value, you could say, okay, this is pure. It's not particularly useful, which is why side effects are needed, but that would be how you have to transform it. Same thing with a random number generator. If you had two functions and one gave you like a random seed, that one could be impure. You could pass that random seed to your random number generator. You would know that the generator at that point is always going to give you the same value, but the seed is still impure. So again, you're just pushing that state, that unpredictable piece up one level, which sometimes is useful, or sometimes in cases like that, seems pretty dumb.
Mm. Yeah, I want a predictable random number generator.
Well,
I don't know what's your problem.
Everything's a pseudo random number generator anyway.
Yeah, I remember seeing some Python library on GitHub that said random number generator guaranteed you won't get two numbers at the same time or the next iteration. I'm like, but then it's not a random number generator.
Yes.
You...
Correct.
Yeah, I was a little sad about that, but yeah, then I went into the issues and a lot of people complained about it, and then I felt better.
Oh, okay, good. That's what the internet's good for, is validating your existing beliefs.
And when you mentioned in React, the top to down trickling, at what point do you decide that this needs to be the, I guess, top one? Like there's shared things between, or like at least shared UI elements that you could or could not reuse between different things, like a form. Where does that generally go? If that's even relevant to functional programming, and just trying to wrap my head around at what point something is higher order enough or something that could be shared,
right,
and still be functional.
So I'll sort of answer it in a related topic. So if it's totally unsatisfactory, let me know.
Then I just suck it up.
No, let me know, and we'll get a better answer. But where I'll go with this is, due to the nature of how React was designed, you end up with as I mentioned, each file or each component just has inputs and has the output. The output can include other components. In other words, it's essentially a recursive data structure for this. It's a tree, is what I'm trying to say. So you have a tree of React components. And because of that, I tend to think of my React apps as just the whole React app is just a series of smaller React apps. And so it'll tend to start at like the route, and whatever route you are then going to, or whatever page you are then going to associate with that route. So if you design your app in such a way that you have, for example, page components, you'll take that page component and say, it's associated with this route. That kind of below the mounted app becomes your top level. And then beneath that, you might have something that is either subroute or, as you mentioned, forms. Forms tend to hold quite a lot of state. And within that, if you have a form library, it'll manage that for you. But say you were handwriting forms for some reason, and you need to store all your state somewhere. It becomes the decision of how high do I need to raise this data in my application such that it can be passed down to the rest of my components and have the state be irrelevant to as many of them as possible. So the way that it'll tend to be done is if you've raised up your state to some sort of shared parent component, that parent component will know how to modify that state in things that it has defined and then pass those as callbacks further down. So if you had like a name field, you could have something like a set name function that the child components have no idea how it works. They just know I was given this callback, and on change, I'm going to call this, and then I'm going to get new data. And that new data happens to be the updated name, but it has no idea how that works. So you end up with this one little piece of state held in this one little place as high up as possible. And then if you look at it as that's a small React app inside of your React app, it has the same structure as the larger React app, which is this thing with Redux bolted on the side. But then if you zoom in, it looks like a tiny React app. And the key is trying to decide for your particular project whether you're going to do something like kick all that state out to Redux, which is what like Redux forms did, and I hate, or if you're going to raise it up inside of your components to some sort of consistent shared level, which for the most part, unless you have really deep components, and so like a ton going on each route, tends to be pretty okay. You have something like a page that just is associated with a route, and then maybe loads up a container, and that container is what will hold your state. And it'll say how to transition from one state to another. That state can just get passed down into the children. 99% of your app then has no idea how that state works. And if you need to deal with it, it's in one spot, very high up in the app. The key is to avoid having state that is at this layer and at the next layer and at the next layer, because then you have no idea what's going on. And as soon as something else has to reference that state, you have to then refactor and drag everything back up. The other approach is to kick everything over to Redux, where you just connect, or whatever state management you're using, where you just connect every single component to Redux, and they're all now stateful, unless you consider the state map state to props to be like preventing that from being stateful somehow. Depends on how you look at it, I guess.
It's in the edges. I don't care. I mean,
Yeah.
it's bolted on, but it's on the edges.
Yeah,
So we're not really sharing because we don't care.
right. And yeah, so there's two different strategies. There's a really good talk about it. If I can find it, I'll link it in the notes and description, because I'm doing a very poor explanation of what a like 45-minute, hour-long talk describes, specifically related to these two approaches and how Redux deals with these problems and how it fails to deal with these problems in some respect. So that would be far better listening than I could do, but that is how I currently think about it.
Okay. That makes sense. I was also thinking in some time future we'll do an episode on React, Redux, Angular, Vue, the front end frameworks, the big ones,
Hmm.
and I'm sure we can touch on it there and rant for 45 minutes about why one is the better than the other.
Yeah, I haven't checked in with either Angular or Vue in quite a while because the last two companies I've worked at, which has been the last almost 3 years, have just been React. And there's not a whole lot of reason for me to look at Angular. And in this town, nobody seems to use Vue. So it's pretty much just like my next job's probably going to want React. My current job wants React, and my previous job wanted React. So I'll just keep trying to get good at React.
Mm. Maybe once they use it, they can't react to anything else because their view is misangulared. Okay, I'll stop. So, what? So besides having an awesome program that you don't have to worry about state, you can expect a proper input to an output, and you can deal with states in some little corner ugly area. Um, what other benefits are there? Why would I just use it for that? I like my database. My databases are great.
Sure. So the big thing for day-to-day developer happiness, I think, is testability.
Mm.
So if you want to test something that's highly stateful, it can be very difficult, and you have to prepare all the state. If it's associated with other things, you have to mock those things. So you'll sometimes have to mock responses, mock existing state, set everything up, then run that little thing you want to test. So for example, a method on some sort of object. Set up all the state for that method to make sense, run that method, hope it gives you the right result, and probably that means check the database to see if it did that correctly. It's a lot of indirection, whereas if instead you had something like that, instead of that method being defined on that object, I'm not saying this is the better approach, but it's easier to test. If you had it as a function that received that object, then you would just define the object, pass it into the function, and the only thing that you have to be aware of is, does it give you back the correctly updated whatever? So at that point, you've removed the database from, if there was a database update in the original implementation, that would be removed and put somewhere else. So perhaps you would get back the staged changes for that object, and then in a subsequent step, you would save them to the database. So it's a different approach, and again, you don't see a lot of it in that style because it defeats the purpose of encapsulation in many ways. But that function in particular has now become very easy to test. And so if you're writing a lot of functions like that are very easy to test, it makes your test coverage much easier, which hopefully helps you avoid regressions and bugs. And yeah, are you having internet issues again? Because you're jumping all over my screen.
Oh, perhaps.
Okay. As long as you can still hear me fine, then we are
I can.
all right.
I heard the whole thing.
Cool. Sweet. So yeah, that's one of the big things that I like about it. In many ways, I just find it more fun as well, realistically. It's a different style than what a lot of people are used to. And writing a lot of code with expressions, for some reason, just feels really nice. I like being able to define something in a way that is a bit more declarative. And based on that was our first episode, the programming episode, or the programming languages one, right?
Yeah.
Yeah, based on our discussion there, I know that you coming from a very procedural background makes a lot more sense on why you'd be like, no, I want to see the for loop. But for me, I love the idea of being able to write a function that says to me exactly what it's going to try to do. So the example I'll always go back to is the sum of all the numbers in an array is the sum of the first two numbers and the sum of the rest of the numbers in the array. So that is the recursive definition for the sum of all the numbers. In other words, if you add the first two and add those two to the rest of the array, you get the sum of all the numbers. And when you write it out and just read that function, it's telling you, I'm going to sum all the numbers in the array. And you're like, oh, okay, cool. Whereas that's no more complicated, in my mind at least, the way that my brain tends to work, than for each number in this array, add current number to sum, return sum. But it feels really nice to me to write it in the functional programming declarative style, so I like doing it. And then, practically speaking, if you're comfortable with those sorts of things, then when you have to deal with something that is recursive, like a linked list or a tree, you can deal with them more easily with less pain and suffering because you enjoy it and you're comfortable with it. So the classic inverted binary tree, it's like 5 lines of recursive code. It is so trivially easy. But if you have no idea how to think about a recursive problem, it's going to seem unfathomable, and then it's just going to throw you off your game. So being comfortable with these things for the appropriate solution is beneficial. But again, if those are only interviews that you're going to never do, maybe it doesn't matter to you. But the day-to-day experience of just writing code like that, to me, is just more fun. And for some reason, I like writing code anyway. So writing it in a particular style, I think, is slightly more fun, and I'll go out of my way to try to do that.
I mean, you've already proved that with your Minecraft thing, and you sending me some message that was in what, Haskell maybe, that had a lot of brackets. Oh no, that was just JavaScript.
Yes. Yeah,
Yeah.
that was a website that you can type any JavaScript into, and it uses just square brackets and maybe the plus operator or it converts it into just those characters. Yeah, JavaScript's type coercion system is kind of bananas. But yeah, it was like 1,500 characters of just pluses and square brackets. And if you ran it, it said, "Hello, Gyan."
Yeah. And I was like, this is why aliens won't visit us. Because you do stuff like that.
Yeah, so
Although,
these sorts of
yes.
things crack me up, so I like doing them.
While you were talking about that, though, I think I may have my next do better from that is I'm going to try the recursion approach to everything. I know I am very resisting towards it, and that's one of the reasons I always find it like exactly as you said. Since I don't enjoy it, it trumps me when it shows up because the first reaction my mind goes to is yuck.
Yeah.
That's all it is. It's just, why would I do it that way when I can write a nice little iterative loop? And for linked list and stuff, I get it. Maybe it's because I like them in recursion, was because that's how they were taught to me when I was learning object oriented and different data types.
Hmm.
So maybe they're not as scary to me, but maybe if they taught me doing those things in iterative fashion, I would have just stuck with those and liked that more. It's just the small amount of recursion that has been shown me, not counting any interview prep I did when it was being taught to me, just never appealed. Because
Hmm.
for me, instead of, okay, I can go at the very bottom of the array, and now that I've hit the end, I'll add these two numbers, come up, add that to that, and then come up, and then unfold the array in a recursive fashion, and it reduces the amount of code. But in my head, I'm like, what's all this unfolding nonsense? It makes no sense. The only thing that makes sense to
See,
me is I 1 plus 1 is 2 now. 2 can go add to 3, which is just doing that in reverse, but I'm going in like a linear fashion, and that somehow like appealed to me a lot more than un check, unpack. Oh, we're done.
yeah, you like stacks, right? Fat
No.
stacks? Oh.
I think when I
Uh,
was learning stacks as the data type, I was like, this is useless. Why don't we just use arrays? And just we can change the index on how we're looking at things. And they were just trying to explain how different data types can be used for modeling real world things. The whole concept of why object oriented exists. And I was just like so against it. I was like, I have an array. That's all I need in my life. I don't need any more data types ever. Yeah. I don't know if that all came through because my internet is saying it's unstable and you're frozen.
All right, well, we're back. Gyan had some internet issues, but we need to pick up where we left off, which is talking about how he's going to love recursion now and use it
Yes.
every day.
Where did I cut off?
Saying that you don't like stacks, just use arrays. And I was going to tell you that you just need to use tail call recursion, or proper tail calls, I should say, for tail call optimization, because you like iterative code, and that's essentially the way to write iterative recursion. Unfortunately, well, not for you because you don't even use it, but JavaScript decided not to keep it, and I don't think Python supports it, which is an actual problem for you. But maybe I just need to find you a language that supports tail call recursion, and then you get the performance benefit of iterative code that you want, and you get to write recursive code, which is generally shorter and more declarative, which you're going to
Wow.
learn to love.
I am going to learn how to love recursion. I'm at least gonna go with my Chris Traeger mindset towards it, and I'm just gonna go into it. So, and yeah, generally when I
Well,
use recursion, sorry, go ahead.
I was just going to say, consider the problem that we were just talking about, right? Of inverting a binary tree. If you had to imperatively navigate through the tree versus saying the left node is going to go on the right node, and then I want you to do that with the left node, except put it on the right node, and then I want you to do the same thing for the left node, and then do the same thing for the right node. And then all that's going to do is swap each node and just navigate through the tree, and eventually is magically just gone through the whole tree and it's swapped every node. It's so trivially easy and wonderful, and it takes care of all of it for you. And you can go through and step through each line and be like, yeah, I guess that's how that would work, and it makes sense. But just thinking about it, you're like, this tree is just a root node with two children, and if they, or two or zero children, if they exist, swap them. If they don't, then you're done. You're at the leaf. So return. And then you just recursively call itself. And because the tree is a tree of trees, it does it for you. So it's those sorts of problems just make me go, recursion's so lovely, and I just want to use it all the time. But I'd actually
This
never do.
also this also explains your stance on just make a little create React app and then make sure it's under a bigger React app and then it's under
Yes,
a bigger React app.
yes,
Yeah,
this is
now
exactly what I'm getting at.
and I get it. I think when I was also taught programming, I was taught to dry run your code every single time on a piece of paper or in your head, execute line by line, and it just made
Right.
sense
That's
in the
hard with
linear
recursion.
fashion, right? That's such so iterative, and that's how I was taught. So when I look at these things, my brain can't immediately like draw an array and have a pointer for each variable and go through it. Uh, it's just like, oh, there's not this. Oh, it's like slowly rendering, and that's what, yeah.
All right. What I was trying to say was that with tail call recursion, you get that same benefit. So instead of thinking of it where it's like a big stack, where you're saying, I want to add the first number in an array, if you're summing the list, to the next number. And then when you get into that next number, when you try to, or the first number to the rest of the array, and then when you invoke that sum the rest of the array, it gets the next number. And then we say sum the rest of the array, it gets the next number. And then that just makes a big stack that again adds, if you had 1 through 10, adds 9 to 10, then 19 to 8, and goes all the way back. That's like the standard way of doing it. If you have tail call recursion involved where you can get tail call optimization, you can rewrite it so that you're saying add the first two numbers. And the recursive structure of it is instead of adding the first number to the sum of the rest of the array, you sum the first two numbers and then add that to the next number, which is going to be added to the sum of the rest of the array. And so the structure ends up being that you add two local variables, they get passed to the next iteration. And so, and then that is now your new first number, which gets passed to the next iteration, which is now your new first number. And so the sum grows as the first index in the array until there's only one number left, which is your base case, or less than one number. and then you return the first number or 0, whatever you have there. And you get to then just discard. The reason it's optimized is you discard all the calls as you go because there's no need to nest them anymore. But you can then think of it as more of an iterative approach where you're saying, add 2 numbers and pass them along. Then get rid of the old state, add 2 numbers, pass them along. That may potentially make things more appealing to you, but regardless, it's an interesting topic that I think people who are a bit more curious about how to optimize recursive code should at least understand, even if they don't work with languages that support it currently, because there are languages that do. And if you're going to write recursive code, you should probably be aware of how to at least make it potentially better at some point in the future.
Yeah, and I can't really imagine most tech companies letting you in unless they throw some random recursive question at you during the interview stages.
Yeah, unfortunately, I've never been asked something like that. If they just asked me like how can you explain tail call optimization, that would be, I'd knock that one out of the park. Instead, it's always some sort of string manipulation problem, which I always fail at. Or a matrix thing, which is also no fun.
It's because you're so innocent. Manipulation is just not in you.
Right. Yeah, I'm a real sweet guy. Anyway, I want to finish off with how people can get started with functional programming stuff and where some people go awry. I'm going to do most of the
I
talking.
know.
Okay.
YouTube.com/ and search for NW Calwing.
Right. Thanks. Yeah,
Sorry,
I do
folks.
have a bunch of videos. They're getting fairly old and of fairly mixed quality. They were mostly recorded on my 2010 MacBook Pro. So when everybody asks, why is this video so trash and why does it look like it was recorded on a potato? Like, well, it was an old computer when I recorded it, even though the recording was in 2017 or something. So the content's of mixed quality, but I tried at the time, and yeah, you can go there. Most of it's fairly beginner focused, and then essentially if you were to jump into the most recent videos and watch like the Monad mini series or Transducers, you're going to probably get annoyed if you haven't been familiar with these topics before, because it'll just be me constantly saying, if you don't understand this, check out this other video. And you'll eventually make it to whatever level of knowledge you actually have. But if you're trying to get into functional programming yourself, one very simple way of doing it is to just start writing some code on your own, probably not at work, but on your own, where you just say, all right, I'm not allowed to use state, and just see what you can come up with. If you're not allowed to use any statements, you're only allowed to use expressions. Like every time you want to use an if statement, I say, nay, you shall not. You shall not use a ternary. And just go in and try to figure out how to do it. How much code can you write before you need to introduce state? Can you write pretty much your entire app with just one piece of state on the outside that you pass in? If you can, then you've probably learned a thing or two. And if you think that's impossible to even write a function without using some sort of shared state, you got work to do. So there are gains to be made there. Otherwise, the basic intro is typically with map, filter, reduce. And those are the most common abstractions. In a language like Python, you've also got zip. Those are really common. Pretty much anything in underscore, .js, Lodash, Ramda, something like that. Those are all, if you're on the front end side, a lot of those utility functions tend to be very functional programming based. But map, filter, reduce are the big ones. If you don't understand the differences between them, watch some videos. I do have videos on all of them. You can watch them there. And once you understand them, I'd get comfortable with using them and then see if you can implement them yourself. They're very trivial if you understand the concept. And I used them for quite a while where I wouldn't, before I was able to implement them properly. And it's kind of weird for me to even think of that because it is such a trivial thing that once you've written the code, you just think, how could I have not understood this concept? But they're really valuable abstractions. Understand them, know how to implement them. And if you're already at that point or you want to go one step further, start trying to wrap your head around how exactly the async monad works. So in JavaScript, that's called promises. And if you understand how promises are implemented, asynchronous callbacks that are chainable, that sort of thing is very, very functional programming heavy. And from there, if you understand all that, you can go to transducers, which are basically just like functional programming brain porn. There's no real need to use them pretty much ever that I can imagine, unless you're using them on heavy data processing applications. But they're fascinating. And if you can understand those really well, you're at least as comfortable with functional programming as I am, and I likely can't give you much more advice past that. So if you understand transducers, I don't think I have much more to teach you. That would be my roadmap. Any thoughts, Gyan?
No, that makes sense. I'm not even at that level yet, so I will go and do better. And
Do you know what transducers are? I'm curious.
I feel like I've Googled this before and they made sense to me because the keyword isn't new to me, but I cannot tell you right now off the top of my head.
Okay, so the TLDR of transducers, they allow you to compose mapping, filtering, and reducing into a single iteration. So if you have, for example, a list of numbers, you wanted to filter some out, you wanted to increment them by 1, and then you wanted to add them all up. Normally you can't compose those because the shape of function expected for a filtering operation is different from that of a mapping operation, is different of that expected for a reducing operation. But with transducers, you can build this composed pipeline of mapping, filtering, reducing, and then just pass the list through, and it goes through one time, doesn't go through 3 times, and you get this performance benefit. But the other cool thing about it, which I get really excited about in my transducing video, is you can use this across any different data type that knows how to transduce. So it essentially uses reduce and concat, I think, is the example I used for JavaScript, because concat is pretty standard in JavaScript. But closure, which is what made this concept popular, I believe they use conj or something like that. And anyway, it's the idea of joining. And so if you have a data set or a data type that knows how to reduce and knows how to join 2 values together, so like concatenating an array, you can pass that through a transducer and get a result. You can pass a totally different data type that has those methods implemented, and you get a new value out, and that data type will be perfectly happy going through that transducer. So it's pretty cool. It's programming to an interface with functional programming, and it just tickles me in all the right ways.
Yes, that is the sentence I was looking for because you seem tickled in all the right
Yeah,
places.
I'm tickled pink.
So, okay, so the next time I'm just like, oh my god, I need a performance nerd, then I can just come to you. At least
If
for
it's
function programming.
Yeah, if it's specific to those couple of things I mentioned, because functional programming is not known for performance. It tends to be more of a resource hog. It's by definition more of an abstraction than most imperative approaches to code. So yeah, you're not going to get performance out of the box. But if you want to do optimizations like tail call optimization or using transducers, they're pretty cool. So I'm a big
Pretty
fan.
cool.
They're pretty cool. I do want to mention briefly before we switch to the final segment how people tend to go astray with functional programming. So if you go on YouTube and you type in functional programming, it's very possible that you will end up at some videos of like middle-aged mathematicians explaining functional programming concepts like monads and monoids, and they are not necessary to understanding functional programming at a practical level, but they will probably confuse the hell out of you. And I would recommend just skipping out on a lot of the math heavy stuff unless you are a math based person. So if you are already doing some sort of higher level education in math, maybe that suits your learning style. But for most software devs out there, if you start learning about why a clock is like a monoid and how you can't fall out of it as a data type, you're just going to go, functional programming's dumb. I don't see why this is beneficial. I just need to make sure I don't get null pointer exceptions and move on with my day. So staying away from that sort of thing, the stuff that's almost by definition like unnecessarily complicated, because that's what those people really like. And just staying away from that if that's not what you're there for. Once you're bought in, once you're using this code, it can be fun to understand the different data types like maybes and ethers and how mathematically they are defined based on type theory. But if type theory isn't interesting to you off the bat, you don't need to start there. It's completely unnecessary for getting started with functional programming. Just go in, use those common abstractions, learn about promises if you're in JavaScript, learn about map filter reduce in pretty much any language. List compositions are a popular thing for Python. Play with those a bit. They're not specifically functional, but they're essentially a good way of doing maps and reduces. Do that, and hopefully you find it interesting. If you don't, maybe you're more like a Gyan than a Nathan, but I would say give it a shot, and don't get lost in the weeds.
Yeah, depending on wherever you end up with on your interest level, go on Twitter, hit Nathan up, and just be like, "Hey, functional programming sucks," regardless if you like it or not, just to trigger him.
Yeah. No matter how you feel. just to get me razzed up a bit.
Yeah, and as we established in one of the previous podcasts, Nathan's Twitter he'll be actively checking that now.
Oh yeah, now that episodes are coming out, I should actually be checking in case we have listeners.
Yeah, I mean, we'll find out when we have listeners, I guess. Maybe.
Yeah, maybe.
But yes, maybe. I just need to make a Twitter handle with NoobMaster69 and then message you.
Yeah, tell me that functional programming sucks and also I suck at Rocket League. Which neither of those may be untrue. It's hard to say.
Yeah.
So
your gameplay is completely impure, man.
Yeah, I've been playing for like 10 days. It's expected that I'm quite bad. Either way, I think that's all I have specific to functional programming. Do you think I missed anything that I should mention? Or are you ready to move on to what we're going to do better and wrap it up?
Yeah, you touched on pretty much everything I crossed out the last time and the new points I wrote down during this. Yeah, so I think we're good, and yeah.
Cool. So I'm going to update everybody on how my weekend, I guess, went of doing better. And it's been great. So to remind everybody, I mentioned last week that I had very poor sleep early on in the week. Things were just not looking good. I was feeling tired, not sleeping well, not feeling my best. And I just kind of took the nuclear option and just tried to fix everything fix it by doing everything I could think of. So yeah, I picked up a bunch of fruits, veggies, multivitamin, tried to get some more sleep. So I've been eating as well as I can, spending as much time outside as I can, even if it's a bit rainy and gross. But we had some sun on the weekend, so I was able to do some more longboarding. That helped. And did some stretching, did some cardio. I was doing cardio for the week prior as well. And it doesn't take long for cardio to sort of come back. I just sort of realized that this is probably the heaviest I've been with the least active, because normally at this time of year I'm still climbing and stuff. But everything's a bit weird right now, so it's like this is probably the fattest and least active I've been, which might be why I feel crummy. I should probably fix that. So adding in some cardio, everything seems to be helping. I pretty much immediately started sleeping a bit better and feeling a bit more chipper in general. So gonna keep that up. And what was my actual note for doing better? Oh, haircut, and continue doing the other stuff. So when I trimmed my beard this morning for this call specifically, I realized the reason, one of the reasons that I haven't got my haircut yet is I keep thinking, well, nobody's really going to see me because we're still more or less stuck in our own places, not allowed to go out and see people. But when I trimmed my beard, I thought, I feel a lot better with my beard trimmed. I should probably just get my hair cut because it's been a good excuse to push it off, but I know I'll feel better if I have my hair cut because I won't feel like I have grandma hair, which is how I currently feel because this is what my grandma's hair looks like. And that's fine for her. It's not fine for me. So I need to get that fixed. And especially now that Gyan's got his hair cut, he's looking all sharp and I'm not. So I'm
Yeah, because
gonna do that.
when I was thinking about getting it done, I kept thinking, okay, I'm going to India in a month. I'll just get it done there. I'm going to a wedding, so I'm sure I'll have to like get some sort of facial fixture done then anyways, so I could pay somebody to do it. And then I realized the only reason I keep putting it off is A, that, and B, it's because I had the same logic of, well, nobody's seeing me. And then I realized I am seeing me.
Yep.
And it's a huge confidence and happiness boost when you like yourself, which is crazy. It's like, it's almost like no therapist has ever talked about this in the history. You
Yeah,
heard it first on this podcast that self love is important.
that's right. Yeah,
Yeah.
so I'm thinking I'm going to do that. Should make me feel better. And in general, if I can just try to approach my day as being like, what if I were trying to look good for like a date? And if I try to do that, then I think I'll be in a good spot. Feeling better, looking better, all those things. All right, Gan, you're back.
Finally, hopefully. Good thing we're near the end, so nobody has to put this up with anymore.
Yes, I just need to know what you're doing next week and how your doing better has gone. And then I guess we sign off. That's pretty much it.
That sounds like a plan, cause if it happens one more time, I may have a broken router on my hand.
Oh, don't do that.
Um, yeah. So for did better, I said I wanted to get back on my coding spree and start maybe playing around with some of the code I used to work on. So I did set up the dev environment again. When you leave a project for the longest time, you have to like go back to it, figure out how everything was set up, because at the time you thought you did everything perfectly. It was so cool. You just needed some commands. For this one, however, I would say I'm still not disappointed. It's still just two commands: thank you, Docker. And they're all makefile commands too. So all I had to do is just like make build and make app, and it runs with hot reloading and everything. However, I have forgotten how I architected the app. So I am tracing through the routes to the wherever things are going and how they're running. But it seems to be working fine. I just need to make sure now it has a little deployment setup, and once I fully understand what my plan for deployment for it would be, I will do that, because I think I'm gonna have a server running some of these different apps just all in one little Docker container. Or maybe I'll use ECS. I'll see which one's cheaper, and yeah, figure out from there. And so that's what I thought I would do better, and I have sort of made progress on it. Not as much as I would have liked, but I played a lot of Horizon Zero Dawn, and that was good. That was good for my mental health. And yeah, and then for doing better, I have a book that I'm halfway through, and I'm gonna finish it this week because I would like to finish two books before January ends. And if I'm almost halfway through this month with this one book, then I can get the other one out as well. Um, yeah, and then do a little bit more work on the bot, time permitting.
Wow. What's the new book?
Oh, the one I'm reading right now is called Outliers by Malcolm Gladwell.
Yeah.
And so far it's very depressing. The first half of that book talks all about how you had to be born, or people who were the most successful were born in a right time at the right place.
Yes.
And had the right circumstances.
Yeah.
I'm just like, this doesn't help me. It's interesting, fascinating data. Maybe college students would be like, cool. This does not help me. This is not a self-help book. And my friend thought it would be a good idea for me to read it. So I'm just holding out hope that maybe on the other half it talks about how they achieved things, even though they were born in a certain time, they had something that helped them be an outlier. Or something along the lines of, this is how you find if you're one, kind of things. So that from my perspective, I can think, okay, they had all these things that made them this. What do I have available to myself so that I can be the best I can be in whatever capacity? So, but if it's all about just, hey, either you were born at the right time or you're screwed, I'm going to be hella depressed.
Right. So is that the book that discusses, Bill Gates going to like the only high school that had a computer, something like that?
Yes,
Yeah.
yeah.
Yeah, I'm familiar. What's the other book?
It's another one from Malcolm Gladwell. I haven't looked at it.
Oh, okay.
It was just, these two were given to me being like, you would like this. And I'm starting to question these persons' recommendations.
Fair enough. All right. So
Yeah,
that's the week. That's the plan.
that's the week.
All right.
It's a very strong plan for the week.
I imagine. Yeah. Yeah. Anyway, we need to wrap this up before we lose you again.
Yes, I'm so sorry. I wish I could say it won't happen again, but I will ask my router to do better.
Good. Yeah. They respond well to requests. It's literally their job. Got him.
It took a second to click.
All right. So thanks
All
for
right,
listening,
well-
everybody. Gyan's dying.
Yes, it's taken me a while to enjoy this pun. I hope you enjoyed this podcast and that excellent pun Nathan made. If you have any follow-ups, please feel free to reach out to Nathan because it's functional programming and he'll be the best contact.
And if you have any puns, send them to Gyan. He loves them.
Yes, absolutely. I will respond to every single person who sends me a pun because I will love you forever.
And that's a
And I know you listen to this, so I already love you.
There you go. That's a promise and a guarantee.
So that's a promise. It's going to resolve.
And with that, thanks for
Bye.
listening.